Okay, today in chemistry, we're going to start chapter 11, stoichiometry, which are calculations involving balanced equations. So let's just review a few things about balanced equations first. But before we get started, you're going to need your calculator, and you're going to need your periodic table. Okay, so balanced equations, so keep in mind that the coefficients will represent the moles of reactants and products, which also relates to the number of particles. So from last chapter, if you'll remember, 1 mole will have 6.02 times 10 to the 23rd particles, whether those are atoms, molecules, formula units, etc. If the reactants or products are in the gaseous state at STP, it also tells you volume. So if you'll recall, 1 mole will occupy 22.4 liters for any gas. So if we're given this balanced equation, N2 plus 3H2 produces 2NH3. If it says show that it obeys the law of conservation, for atoms, you would say you have 2 atoms of nitrogen and 6 atoms hydrogen. And on the product side, you have 2 atoms nitrogen and 6 atoms hydrogen. So it just wants you to realize that you're going to conserve your elements. Okay, then it says do it by, show that it obeys the law of conservation of mass. So then N2, so you take 14 and it's double since it's N2, so that's 28 grams for your nitrogen. And you have 2 grams for your hydrogen, but you have three of them, so 3 moles of that's 6. So 28 plus 6, you have 34 grams of reactant. So you should have 34 grams of product in this balanced equation. So NH3 ammonia has a mass of 17 grams, 1 nitrogen and 3 hydrogens, and you have 2 of them. So that gives you 34 grams of product. So your reactants mass should equal your products. Okay, so the next one says, interpret the following equation. 2H2S combines with 3 oxygens to produce 2 sulfur dioxides and 2 waters. Now, number of moles, so remember the coefficients in front. We sometimes say they represent molecules, but they don't. They represent moles. So in this equation up here, it would be 1 mole of N2 and 3 moles of H2. So here you say you have 2 moles of H2, H2S, excuse me, reacts with 3 moles oxygen, or O2, 2 produce, or 2 yield, or 2 make, 2 moles sulfur dioxide, and 2 moles water. And then it asks you to show that it obeys the law of conservation of mass. So if you want to put the video on pause and complete that for me. So your H2S weighs 34.1 and you have 2 moles. So that is going to be 68.2 grams. Plus O2 is 32 and you have 3 moles, so that's going to be 96. So you have a total of 164.2 grams of reactants. And so let's see if we have the same amount of product. So you have SO2. SO2 weighs 64.1. So 32.1 for sulfur and 2 oxygens is 32. And you have 2 moles of them. So that gives us 128.2 grams for our sulfur dioxide. Plus water is 18 grams and you have 2 moles, so that is 36. So when you add 36 and 128.2, you get 164.2 grams product. So your reactants and your products mass should be the same, okay? All right, so now let's move on to stoichiometry. So when we talk stoichiometry, you have a balanced equation, and every stoichiometric problem will involve something called a mole ratio. So it says for the equation 2H plus O2 yields 2 waters. What are all the possible mole ratios? So we're going to take 2H2 and we're going to go to oxygen. So if you have 2 moles H2, you need 1 mole oxygen. That's 1 mole ratio. Or we can take our H2 and go to water. So for every 2 moles H2, you're going to produce 2 moles water. Okay? Or now what if we start with O2? For every 1 mole O2, you need 2 moles H2. Or another mole ratio would be 1 mole O2 produces 2 moles water. Or what if we started with water? So for every 2 moles water produced, you need 2 moles H2. And last but not least, for every 2 moles water produced, you need 1 mole O2. So what we did was just list all the possible mole ratios. Now, when we start actual problems, you're only going to have 1 mole ratio per problem. Okay, so number 1, you always start with a balanced equation. If I give you an equation and it's got coefficients in front, it is already balanced. Sometimes I'll say in the unbalanced equation, then you need to balance. So for each problem, regardless of the number of different compounds found in the balanced equation, you will only use 2. Read the problem to find out which ones. One will be your starting substance and one will be the desired. And then you'll determine the moles of the starting substance. So you'll identify the starting substance, so it will be found in the problem. We'll have a number with it. When the starting substance is given in moles, use it in that form. If it is not in moles, then you'll convert the quantity of the starting substance to moles. Then you'll determine the mole ratio of the desired substance to the starting substance. Remember, the coefficient in front of each substance is the number of moles. So the mole ratio is always going to be starting substance to desired. And then you'll calculate the moles of desired substance. Okay, so let's go down and actually just work a problem. It's a lot easier just to practice a few. So it says how many moles of water will be produced from 3.5 moles of magnesium hydroxide according to this reaction. The easiest thing you can do is write stuff above. So you have 3.5 moles magnesium hydroxide. So above magnesium hydroxide, write 3.5 moles. And you want to know how many moles water. So your question mark moles is going to go above water. So that means for this problem, our mole ratio is going to be this to this. So we're not going to involve these. So you have 3.5 moles MgOH2 times, now go to your balanced equation. For every 1 mole MgOH2, you're going to produce 2 moles water. Okay? Mole MgOH2 will cancel. You're going to be left with mole water, which is what it's asking for. You're going to multiply across the top, divide by the bottom. So 3.5 times 2 is 7. This number here has 2 sig figs, so we're going to put our answer in 2. So your answer is 7.0 moles of water. Okay, the next one, how many moles of ammonia can be produced from 8 moles of hydrogen reacting with nitrogen? So we're missing a balanced equation. So our reactants are H2 plus N2. Remember, they're diatomic when they're by themselves, and they're going to make ammonia, which is NH3. We're going to put a 2 here to balance, and we're going to put a 3 here. So it says how many moles of ammonia, so this is ammonia, question mark moles, can be produced from 8 moles of hydrogen. So you're going to start with the thing with the number first. You're going to say 8 moles hydrogen times division bar. You want to get rid of moles hydrogen, so it's going to go on the bottom. You go to your balanced equation. You have 3 moles of hydrogen. You are going to ammonia, so you put mole ammonia on top, and we have 2 moles. That's your mole ratio. Cancel out mole H2, so you multiply 8 times 2 is 16. Divided by 3 gives you 5.33, and you want 3 sig figs. Make sure all your numbers have units and the compound or element you're working with. Okay? Okay, so if you want to put the video on pause for a second and work your next example. Okay, so it says calculate the moles of K2SR, K2CR2O7, so you want question mark moles, and you have 2 moles Ki. So above Ki, we're going to put a 2 moles. So we're asking if we have 2 moles Ki, how much of this do we really need to react with this? You're going to say 2 moles Ki times division bar. Go to your balanced equation. You have 6 moles Ki, so this is your mole ratio step. For every 1 mole K2CR2O7, okay? Mole KO will cancel. You multiply across the top. 2 times 1 is 2 divided by 6 should give you 0.33 mole K2 Cr2O7. Now the next question says, how many moles of iodine can we make from the 2 moles Ki? So we're going to say 2 moles Ki times division bar for every 6 moles Ki. You have 3 moles I2. Moles Ki cancel. 2 times 3 is 6. Divided by 6 is 1. You want 2 sig figs, 1.0 mole of iodine. So if you only have 2 moles Ki, you're only going to produce 1 mole of iodine. And then the last one, you have 4.68 moles sulfuric acid. And you want to go to water. So you go to your balanced equation. So we have 7 moles sulfuric acid for every 7 moles water produced. So to do your math, well, 7 divided by 7 is 1, so your answer is going to simply be 4.68 moles water. So mole are pretty simple, okay? Now, sometimes you may not start with mole, or you may not want to find mole. You may want to find mass or start with mass. And so it's the same thing. It's just you got to get your beginning thing to mole and then take it to where it wants you to. So it says, what mass of hydrogen can be produced by reacting 6 moles of aluminum with HCl? So we need to write a balanced equation. So we have Al plus HCl, hydrochloric acid, will give you AlCl3, single displacement, plus hydrogen gas. We're going to put a 2 here. That gives you 6 chlorine, so we're going to put a 6 here. We're going to put a 3 here and a 2 here, okay? So it says, what mass of hydrogen, so this is a question mark grams this time because mass is grams, can we produce from reacting 6 moles of aluminum? So your beginning thing's in moles, so you just say 6 moles of aluminum times division bar, go to your balanced equation. For every 2 moles of aluminum, you have 3 moles H2. But we don't want mole H2, we want grams, so we're going to go times. For every 1 mole H2, there are 2 grams. Do not automatically bring this 3 over. This is from the table, so it's in 1 mole. All right? And let me say this, you cannot go from mole A2 directly to grams H2. You've got to go through your mole-mole ratio. Okay, so in your calculator, I multiply across the top. So 6 times 3 is 18, times 2, divided by 2, turns out to be 18 grams of hydrogen. So if you have 6 moles of aluminum, you can produce 18 grams of hydrogen. Okay, the next one, what mass of carbon dioxide? So you want grams, mass, question mark grams, and you're starting with 100 grams of this. Okay, so now this time it's different. Your beginning thing is not in moles, it's in grams. So step 1 is to get it to moles. So you say 100 grams C5H12 times grams C5H12 in 1 mole. So you go to your table. And 5 times 2 is 12. 5 times 12 is 60, pardon me, plus 12 is 72. I've done this video twice and it didn't upload, so I'm getting a little leery. Okay, and then you go to your balanced equation. For every 1 mole C5H12, you produce 5 moles CO2. So grams C5H12 cancels, mole C5H12 cancels. You don't want mole CO2, you want grams, so we're going to say times. We want to go from mole CO2 to gram CO2. You're going to look this mass up in the table, and that's per 1 mole. So carbon is 12, oxygen, 2 oxygens are 32, so that's 44.0 grams. So we're going to multiply across the top, so you're going to say 100 times 5 times 44 divided by 72. So you should be able to produce 306 grams of CO2, okay? Next one, you want to know how many moles of nitric acid. So nitric acid is HNO3, you want question mark mole. Are required to produce 8.7 grams dinitrogen monoxide, so that's N2O. So you want to produce this, and you want to know how many moles of that. So you say 8.75 grams N2O times, we've got to get grams to mole. So you're going to look up 2 nitrogens, 1 oxygen. So that's 28 and 16, it should be 44 grams. Times, go to your balanced equation. For every 1 mole N2O, you need 10 moles HNO3. Your grams N2O cancel, your mole N2O cancel. You're left with mole HNO3, which is what the question's asking for. So you're going to multiply across the top. You're going to say 8.75 times 10 divide by 44 gives you 1.99. So you need 1.99 moles of HNO3 if you want to produce 8.75 grams. Okay, a couple of more. So this one, you're going to have to write a balanced equation. So you have AgNO3 reacting with NaCl, and it tells you one of your products is going to be AgCl. This is double displacement, and then Na is going to combine with NO3. This one's simple because we don't have to do anything to balance. It's already balanced. So how many grams of AgCl? So that's question mark grams. If you have 17 grams AgNO3, okay? So you're going to start with 17 grams AgNO3 times grams AgNO3 in 1 mole. So you can look these masses up on the table. Silver is 107.9, 14, and then 48 gives you 169.9. Times, go to your balanced equation. For every 1 mole AgNO3, you have 1 mole AgCl. We don't want mole, we want grams, so we're going to say times. In 1 mole AgCl, you have 143.4 grams. Okay? Grams AgNO3 cancels, mole AgNO3 cancels, mole AgCl cancels. You're left with grams AgCl. So you're going to multiply across the top. So you're going to take 17 times 143.4 divide by 169.9 should give you 14.4 grams. Okay? And then I think you have to write a balanced equation on this one. So you want to know how many grams Cu2S can be produced from CuCl reacting with H2S. So your reactants are CuCl and H2S. And you're going to make Cu2S, and H is going to combine with Cl, HCl. You're going to put a 2 here to balance and a 2 here, okay? Okay, so you have 9.9 grams of CuCl, and you want to know grams of Cu2S. Okay, so you're going to say 9.9 grams CuCl times, there are 99.9 grams CuCl in 1 mole. So go to the table and look up copper and 1 chlorine. Go to your balanced equation. For every 2 moles CuCl, you have 1 mole Cu2S. We don't want mole, we want grams, so we're going to go times every 1 mole Cu2S. Go to the table and look up 2 coppers and 1 sulfur. Should be 159.1. Okay? So I think it's easiest to multiply across the top, then divide by the bottom. So 9.9 times 159.1 divide by 2 divide by 99.9 should give you 7.9 grams Cu2S. All right, so that is the first part of stoichiometry, and this should help you do your homework set 1. Thank you.